je.
Assalamualaikum warahmatullahi wabarakatuh. So today we are going to do presentation by group for subject MTES3362 Introduction to Geometry. So this is my group members, which is me myself, Nur Hasana, Ayani Ayuni, and also Nurjana Afika. Okay, so first of all, let's take a look for what is the meaning of paper engineering. Paper engineering encompasses the art and science of manipulating paper to create dynamic and engaging structures, particularly pop-up elements and other movable mechanisms. It's a field that combines elements of engineering, mathematics, and design to bring paper-based creations to life. This can range from pop-up cards and books to complex architectural models and even interactive displays. So this is some aspects of paper engineering, which is first, understanding paper properties. Paper's characteristics such as strength, flexibility, and how it bends and folds are crucial for creating functional and visually appealing structures. Number two, design and mathematics. Paper engineering, precise cuts, folds, and connections are necessary for achieving desired movements and shape. And for aspects number three, for mechanism and movement. Paper engineering utilizes various mechanisms like folds, cuts, and tabs to create dynamic elements like pop-up sliders and also rotating parts. So there is many applications of paper engineering. There is I put here some of the application, which is first of all for interactive books and cards. Paper engineering helps us to create an engaging dynamic stories and also building. Number two, for architectural models and prototypes. Paper engineering helps us to design and visualizing structures and also spaces. For number three, for display and packaging, it helps us to develop eye-catching and functional packaging solutions.
Now, let's take a closer look at the structure of our pop-up book. We carefully designed it with three main interactive elements, each representing a different way to engage with the concept of the great dodecahedron. The layout is arranged in a three-panel format, left, center, and right, so that when the book is fully open, all three components are visible at once. Let's begin with the centerpiece. Here, we have placed a striking 3D image of the great dodecahedron, which appears as the book is opened. Although it's a printed image rather than a physical model, it is designed to create the illusion of depth and dimension, immediately capturing the viewer's attention. The shape was chosen as the focal point because of its unique and captivating form, often recognized in the world of geometry for its complexity and beauty. We decided to introduce this shape first to spark curiosity. The way it appears in 3D grabs attention and encourages viewers to explore more. Next, on the left-hand side, we create a waterfall flip card. This is a classic paper engineering feature that introduces movement and interactivity. When you pull the tab, a series of cards flip over. One card explains that the great dodecahedron is one of the Kepler pointsod polyhedra. Another card shows its mathematical feature, like the number of faces, edges, and vertices. We also included some fun trivia to keep readers engaged. The idea here is to break down the information into bite sizes, digestible parts, kind of like a mini pop-up encyclopedia. Finally, on the right-hand panel, we included an interactive sliding mechanism. This part starts as a flat net or unfolded version of the great dodecahedron, but when you gently pull the paper marked pull, the sheet lifts and stands up vertically, and underneath that, we added a QR code, which is only revealed once the sheet is fully pulled up. The QR code links to a video that provides further explanation on how to construct the great dodecahedron, giving the user a way to extend their learning beyond the book. This section adds a surprise element and blends physical paper mechanics with digital interactivity. So, altogether, our pop-up book offers visual, tactile, and interactive learning experience combining creative paper engineering with mathematical concept in a way that both fun and educational.
So this is our pop-up book. For our pop-up book, we put A3 paper into A4 paper by using half fold, which is this is the simplest of the fold type, which goes by BEX. It has a single fold that divides the paper into two equal parts, resulting in four sealed leaf panels, two on the front and two on the back. So when used with flyer stock pamphlets, half-fold pamphlets are perfect for marketing sales or even promotions. With sticker and cardstock pamphlets, it can be used to create double-sized business card, point card, or greeting cards. So for the outside top, it has back cover and also front cover, which is this and this. For the inside top, it has the inside left and also inside right. So after folding, we have back cover and also inside right, and this is the front cover. Okay, so for element 1, this is the element 1, a 3D image of the great dodecahedron. This shape is not just visually stunning, but it also represents one of the more advanced polyhedra in mathematical geometry, which is this is the great dodecahedron. Okay, for part 1, we use belly fold structure. This part uses a belly fold, which is a basic folding technique in paper craft and origami. A belly fold happens when the paper is folded inward, creating a V-shaped dip, just like a belly in a chair. In paper engineering, belly folds are important because they help create movement, layers, and pop-up effects. For example, in this design, the belly fold allows the 3D shapes polyhedra to stand up when the paper is open, giving a dynamic and interactive element to the display. So this technique adds depth and dimensions to the presentation, making it more interactive and also engaging.
Now, let's focus on the second element of our pop-up book, which is the waterfall flip card. It is a type of interactive mechanism that involves a series of cards connected to a base strip where pulling a single tab causes each card to flip over in sequence, revealing new content with each movement. This design creates a dynamic storytelling or information sharing experience. So, we have number 1, pull tab mechanism. This technique uses a long strip of paper, commonly referred to as a pull tab, which slides beneath the flip cards. As the tab is pulled downward, each flip card catches on the strip and flips over one at a time. This is a classic technique in interactive paper design. The motion relies on accurate positioning and spacing of the cards, so that each one flips in the correct order. If the alignment is off, if even by a little, the motion may not work correctly, so precision is very important here. For the second, we have parallel fold. In a waterfall card, each flip panel is connected using folds that run parallel to one another. This means the folds are aligned in the same direction and maintain equal distance and symmetry across the structure. The purpose of this parallel folds is to ensure that every panel moves in the same direction and along the same axis when the tab is pulled. This creates unfiled flipping action. Without the parallel fold, the panels might tilt, shift awkwardly, or not flip properly. For the third one, layer assembly structure. Each flip panel is arranged slightly overlapping the next with equal spacing between them. This layer arrangement is important to prevent the panels from sticking together or blocking one another. It also helps manage space within the limit area of the page. The layering shows the flipped cards to fall neatly on top of each other and to be revealed one by one as we pull the tag. Planning this structure requires careful measurement. Even small mistakes in spacing or alignment can affect how well the flip sequence works. This shows how important accuracy and planning are in paper engineering projects.
So, we move to the third element, which is pop-up slider